So let me start actually now to speak about system design for sustainability. So finally, about design. And we said, okay, and you said, we understood this S.PSS, why it's interesting. And but the point is, it's not just as a product to be designed, and it's an artifact made in a different way, and we have to design it even in a sustainable, so to address a process towards sustainable solution in environmental and socio-ethical terms. So what is this about? You said that you remember, but I will make a very short resume. I have 2 slides about the main characteristic of S.PSS. Then I will really discuss with you system design for sustainability, definition, main approaches, and skills. Then we will see some criteria linked to environmental, to address product service system design towards environmental promising solution. And then 6 socio-ethical criteria that we have defined to address this process towards socio-ethical beneficial solution. All right? We understood that these are quite complex issues, and so we have been working in translating this complex issue in something that is manageable by the designer as a support knowledge and then support tools. And then one final remark about the fact that it's important to give priority to these criteria, but we will come to this later. Main characteristics. So you said that you remember very well. You want to help me to say something? For example, you remember the definition of sustainable product service system as a business model? This is a key point of why we are working and we have been studying this business model, okay? Because it is for an economic and competitive interest that the company providing, and here I can add something, come to the definition, not just product, but a mix of product and services. But this is a business model made in such a way in which the provider, for economic reason, want to design product with a low environmental impact, reducing consumption of resources, material, extending the life of the product, intensifying the use, and all the other things that we discussed very briefly in a short lecture on product lifecycle design. Okay, that was what you were saying. So it's even about that, but it's to design the system to make this design of the product with a low environmental impact effective even in terms of the profit. Adding, as she said, actually, even the socio-ethical dimension. So it's an offer model providing an integrated mix of products and services that are together able to satisfy what we call a unit of satisfaction, a particular demands, like eating in the Bovisa campus. It will be the design exercise of yours, or having clean clothes in a given context. So this is a unit of satisfaction, okay? And this is based on what? And this is another very important thing, based on the innovative interaction of the stakeholder that are part of the satisfaction system. Who's providing the product, maybe the energy that is used by the product, the final user who's dealing with the waste management at the end of the life cycle, and so on. And is a sustainable, so such a mix of product and services that for economic and competitive reason lead towards beneficial solution in terms of environmental and socio-ethical benefit. Okay? Are we there all? You remember now? Okay? And so to sum up, if we look at the traditional business model where we are selling product, the paradigm shift is defined, I was highlighting three changes in the business offer. One is that we move from selling only product, all right? We're not just selling product, to selling unit of satisfaction. And we will come to this later. So I'm not selling a car, I'm selling a mobility, or maybe neither a mobility. I'm selling the possibility to go to meet a friend, which is a type of mobility. That is the unit of satisfaction, what I'm satisfied of, all right? The other thing that characterizes this is that the customer perceived value is not in the ownership of the product. I have my car, but on the access and what this is giving to me. Like, for example, you know very well, it's very easy to be understood, the car sharing. It's not of having a car, but being able to have a car to move and to go somewhere. All right? And the other thing is that the innovation is even technological at the end, that it's very important. But at the beginning is in terms of innovative interaction among the stakeholders, new business models. I'm interacting with the customer in different way and not selling you the product. I'm retaining the ownership as manufacturer, and then maybe I'm offering you service during the life, like maintenance and so on, which is included in the cost that you are paying per use of the product that you're receiving. Okay? And then there is one last part that is definitely important, is the reason why I'm making this course here on sustainability, that this has win-win potential for sustainability. So our business model in which, and I cannot lose now the time to describe this here, the example will come later, if not, I make a second lecture. But you should remember that for economic and competitive reason, if we are into this business model, the company is interested to design long-lasting product because they save the ownership. I'm already saying something like that. Design to reduce consumption of resources during use, design for recycling, for economic and competitive reasons. They are interested in doing all those kind of things. And at the same time, to produce for their economic benefit, even socio-ethical benefits. Because basically they give access to low and middle income people to product and services, either final user or entrepreneurs. Okay? You remember something more now? Said this, it was a very, very short thing we said nearly 4 hours last time. Let's speak about system design for sustainability. And now we start from a definition, but this definition can really straight away from what I said before, from the definition of the business model of sustainable product service system. We said it did. So the definition would be to design what? A system of products and services that together are able to deliver a unit of satisfaction, a peculiar demand by the customer, based on the design of an innovative interaction among stakeholders. It's coming from, and such innovative interaction among stakeholders that, for economic and competitive reasons, make the offer of the product and the services to be environmentally and socio-ethically sustainable. Okay? So This is a kind of a definition, and it's a kind of a framework of a role of the designer. But let me go a little bit more into the detailing this in terms of approach and skills. So what are the new approaches and the new skills compared to traditional product design? The first approach, we have to have a satisfaction system approach. We have to design thinking to the unit of satisfaction. The car, no. Stop there. You are not designing a car. You are not designing a car. What a car is used for. Or in that context, what you are interested, what you are designing for a given context, some people, a given situation. What is the unit of satisfaction? What they want to have. With a car, they want to reach friends, person, get a recipe, I don't know. So we have to think to that. So we have to make one step behind. Stop. Don't think about it, the hardware there. Think about the unit of satisfaction. Okay, this is very important. And I want to add a little bit about that because it's so important. So it's not a single product to be designed or that you assess in environmental or in socio-ethical terms, but actually all the products and the services that are all together giving you a satisfaction. For example, if you want to go from one place to the other, it's not enough to have a car. You have to have the infrastructure, the street on which you move. You have to have the gasoline if you're using gasoline, or if it's solar power, the solar panel on the roof and other things, and so on, right? So in this sense, what we say is that we have to identify or define a unit of satisfaction. And again, here I made an example about the car, so I'm a bit, maybe I'm a bit repeating something, but I think it's a bit needed now. A car. If you remember anything of what we said about life cycle design of products, we said what was important and what we understood in the 90s about designing products with a low environmental impact is that we have to define a functional unit. You remember the example of the cardboard seat compared to the other one? That the cardboard seat in the life cycle, it's very good compared to a Herman Miller chair made of metal and polymers and whatever, but the fact that that lasts for 12 years and the other for nothing because it's destroyed in a while makes that, in terms of the function is to be seated for a given period of time in a given context and so on, makes that chair much better than the other. So when we think about a product, a car, we may define a functional unit as the transportation of one person per 1 kilometer. I identify one function that is given by that car. But if we move from product to system, to wider system and to satisfaction or unit of satisfaction, actually with a car it's possible to do different things, as I even said it before. We can have one first satisfaction that we can have throughout a car is like, for example, I'm not using a car, sometimes car sharing, okay, but I could be coming here at my working place at the university. So the satisfaction could be, the unit of satisfaction could be with the car to reach the working place. Okay, so this is a unit of satisfaction. But actually with a car, what else we can do? Very many other things, right? Like for example, satisfaction 2, unit of satisfaction 2 is that I can get some document that I need for some certification by the municipality of Milan for, I don't know, for doing something. So I need to reach the place, but it's totally different though I'm using the car to reach the place. And of course I can add very many other things. Okay. One point here is that actually, if I'm in some of those cases, the car is neither needed. Okay, if I have to reach a person, maybe I don't need a car, or I can have a different type of car. Something, a mobility system needs to be set in place. But or you trust in Star Trek, so you can move with different type of science fiction system. But if I need to get a document by the municipality of Milan, frankly speaking, I really don't need to have a car. I can get this document through internet in different ways. And I made a very easy example that we can cure people now with long distance treatment and something like this. Okay? So the point is that when you think about a unit of satisfaction, some product may even disappear compared to what you are originally thinking. So even in terms of the radicality of the innovation, you remember we need to change dramatically, reduce dramatically the consumption of resources. The fact of thinking in terms of functional unit led us, as designer, great freedom of great, really greater, much more radical innovation. If we want to say differently, we can say that there are two characteristics that are peculiar of the unit of satisfaction, or designing in relation to the unit of satisfaction. The first one is that we are designing and thinking more deeper. When you design a car, you stop with the car. Okay, you don't think how the car is used, and so, but it's just the car who's producing the car and so on. If you think I have to design the unit of satisfaction of getting that document from the municipality of Milan, okay, there is the fact that I'm here, I have to get in touch with someone that has to deliver the document has to be delivered, I have to reach this person, or the document has to reach me. So into the unit of satisfaction, I have to go deeper. It's not just a stop to the car. I encounter many other products, many other services, many other stakeholders that maybe are providing these products and services. So actually it's deeper. It's deeper, but at the same time it's more narrow. With a car, you can do different things, as we said before. When you are thinking to this, you are narrowing down when you are designing and when you are evaluating to a given unit of satisfaction. I want to have a good eating and sustainable system for the Bovisa campus here in Polytechnic of Milan. This is the one. Okay? So it's deeper, but maybe it's more narrow. So here is a definition, blah, 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 blah. So I can read it, but I hope that you get the point. So it's a quantified satisfaction of a customer, defining all products and services associated with its fulfillment, used as a reference unit to design and evaluate the sustainability impacts as well as benefits. Okay? Let's go on. A second key approach and related skill. A second key approach is that we as designer, you as designer, we have to have or adopt what we call a stakeholder configuration approach. What does it mean? That as designer, we have to have the skill to design the interaction among the stakeholders. I give you here a visualization of this. This is a tool. Maybe some of you are familiar. This is a system map. How many among you know the system map? Students from PSST? For sure they have used this way or others. Okay. So what we find here in this system map, we find the stakeholder, the actor of a satisfaction system, and the interaction among these different actors. Information flow, financial flow, material flow, labor flow, and so on. Okay? So what we have to be able to design is this, the configuration of the system, the actors, and their interaction. This is what we have to design. Many times I make a comparison with the product design. In a product design, like for this laptop here, I have some components and I have the joining elements between these components. Okay, I have some part, this glass here, the other case, and some joining elements, some snap fit, some screws, and so on. If I move to a system level, the components are not the material with a given shape and performances, are the stakeholder, the socio-economical actors, even them with their peculiar characteristics. You know, like a plastic may have a given performance, and actors may have some given performance on a different level. And which are the joining elements? Which are the snap fit or the screws on a system level? Are the interaction among the different components, the different stakeholders. So interaction in terms of financial flows, material flows, and so on. Okay? So this is what we have to design. And we have to design it. We have to be creative in designing it. Okay? You said, how can I be creative? Some of the students have been already working on PSST, may be familiar, or even from other university where this is part of their studies. For the other, you will see that that's very interesting. And finally, of course, because we have to design sustainable product service system. You remember, I said the other time, not all product service systems are sustainable. We have to design such a stakeholder interaction among the actors that, for competitive and economic reasons, make the offer to be environmentally and socioethically sustainable. So we have to design this configuration, be creative and whatever, but to design this to be sustainable. As when we are designing a product, we can design a product and it could be sustainable or not. And we have to have a knowledge about it. We have to have some tool to support us in the design process. The same on a system level. Different type of knowledge, something similar but different type of tools and so on. So basically, we need some criteria and guidelines. This is what we are going to see in a while. And we need some method and tools to help us, as designers during the design process. Okay, as an operative tool. So now I'm going to introduce you the criteria related to the environmental and economic dimension. I will say something very briefly, but they will be discussed through example right after. So this is just an introduction, okay? It will be much nicer right after. Okay, but just follow me to have the overall frame. So the system design for eco-efficiency criteria, eco-efficiency means environmental and economic efficiency, are system life optimization, transportation distribution reduction, resource reduction, waste minimization valorization, conservation biocompatibility, and toxicity reduction. You remember these are quite similar to the criteria that we saw for product lifecycle design. There are some differences because we are speaking, for example, about system life optimization, not product. Because when you're thinking about a product, you have just one product. On a system, you may have several products, and you have to think about the optimization of the overall sum of the product that are part of the system. We have a criteria which is not present as a main criteria in product design, which is transportation. But when you're thinking on a system level, you may understand that since you have to deal with a wider system with different stakeholder, transportation rise higher importance. So this is, has been upgraded to the level of criteria instead of the guidelines and so on. But here I want to say a few things about each of those very briefly. So system life optimization, even to remind you which were the meaning of these criteria when we explore them in product lifecycle design. It means to design for system stakeholder interaction. Remember this, we are designing at first system stakeholder interaction, then the technology, okay? System stakeholder interaction, fostering for economic and competitive reason what? You remember what system life optimization of product, what was about, you remember? The producer, the manufacturer, design something that lasts long. So to extend the life of the product or to intensify the use of the product so that the product is used in a more intensive way. Not just one product, but the sum of the product being part of a system. And you remember this scheme, why we said, why it's interesting to have a long-lasting product? Because if a product lasts longer, which is the case shown in the lower part, you remember the different phases of the life cycle of a product, pre-production, production, distribution, use and disposal, and so on. All right? If a product lasts longer compared to the upper in which it goes in disposal, we avoid the disposal and we avoid the pre-production, production, and distribution of the product that need to be substituted. If the chair is broken and I need to be seated again, I need to produce, and distribute, and to have the chair here again, and I need to dispose the other. So I avoid those impacts. As well as if I'm intensifying the use of a product, for example, we are sharing a computer, it means that one computer is enough for 3 persons, and so we don't have to pre-produce, transport, and dispose 3 computers. So we avoid a pre-production, production, distribution, and disposal of at least 2 of those. Okay, the discussion will be a bit more complex, but just to remind you the main thing. Another criteria is transportation and distribution reduction. So it means to design, now you should say, you should know the word, and speak on my behalf, such a stakeholder interaction that for economic and competitive reason leads to what? Transportation is and distribution is linked to transportation, but as well as packaging when you speak about, so that for the business model is made in a certain way that the company are interested in reducing transportation and packaging. the overall transportation package. Resource reduction, either energy or material, designed for such a stakeholder interaction that for economic and competitive reasons leads to the overall reduction of both energy and material consumption during the life cycle of all the product being part of the system. Waste minimization and valorization, it means to design for such a stakeholder interaction, fostering for economic and competitive reason. You remember how we can valorize the waste in terms of environmental benefits. We don't have to put it to landfill, but we can do what? We can work for recycling, or reuse is more related to if you use a component to the extension of the life of a product. Okay, so it's another thing. And here was the scheme highlighting below we have a product with an extended life, and up we have a product which is not without an extended life. So we avoid the landfill processes, we avoid the pre-production of the material that is recycled or the energy that is recovered, but we may have some additional processes related to the fact that when I'm recycling something or energy recovering, anyhow I have to transport it to some processes and so on. So they are lighter impact, but we have to measure and to design this well. Conservation and biocompatibility, designed for stakeholder interaction, fostering for economic and competitive reasons the overall improvement of the level of renewability of the resources, of conservation of the resources, either material or energy that are part of the system. You remember conservation and renewability, so that they won't be. Toxicity reduction, so designed for such a stakeholder interaction that for economic and competitive reasons lead to what? To an overall reduction or avoidance of the toxicity or harmfulness of the product or the emission that is given in the life cycle of not just one product, but all of the products of the system. Okay, so these are the 6 criteria, just to remember you about those. It will become much nicer when you will see the example of S.PSS that are leading towards this. But here I want to already highlight, and you will see that that for each of those criteria we have developed in the course of several years guidelines for each of the criteria to help designer, through the design process. The point is that those guidelines are not on a product level, but on a stakeholder interaction level. We will see them. This is one of the tools that you will be using. It's called the Sustainability Design Orienting Toolkit. This is one part of the tool. There are idea generation tables on system level. You can see there are the 6 criteria that I just mentioned. And there inside you will find the guidelines that will be explained later with a link to the example. These are idea tables so that you can brainstorm and generate idea, having having some insight from the guidelines or from the example to facilitate the brainstorming and so on. But you will see, and I can read just the first guideline, that the guideline is to complement product or infrastructure with services for their maintenance, repairability, and substitution. I'm not speaking about the technical characteristic of a product, so to design for easy disassembly of. No, I'm speaking about a type of interaction among the who's providing the service and the customer that is promising in relation to, in this case, life cycle optimization. Okay? Now we will see the 6 criteria for the socio-ethical dimension. Improve employment and working conditions, increase equity and justice in relation to stakeholders, enable responsible, sustainable consumption, favor, integrate weak and marginalized, improve social cohesion, and empower and enhance local resources. So, with the first one, improve employment and working conditions, it's quite easy to be said, right? It's quite clear. Though again, we have to think in terms of designing such an interaction among the stakeholder that for economic and competitive reasons lead to an improvement in employment and working conditions. These, among the 6 criteria of the socio-ethical dimension, is the one in which the role of the designer is quite weak. We cannot do that much, all right? You will see that with other we can do more, but we can emphasize this and something we can do, but not that much. And this is something that is happening within the company, okay? Because I'm working to improve employment and working conditions, so basically within the company. Improve equity and justice in relation to the stakeholder. In this case, I'm working outside enterprise, looking at the value production chain of my relation to my unit of satisfaction. So upstream, when I'm producing, I don't know, if we are, you will be designing for the eating system in Bovisa campus, someone has to produce the tomatoes that you're going to eat, and then this has to be transported, and this has to be preserved, and then this has to be cooked, and then eaten, basically by you, and then, you know, all these kind of things. And so the point is that there are several stakeholders along the value production system, and that means to design such a stakeholder interaction that is fair, that produces a fair and just relation with these other stakeholders. Okay? And this could be actually because you made a partnership as a company with other in the offer. So even within the partnership, upstream, of course, you have to look upstream, but even downstream. So maybe to the distributor or to the end user, of course, or to the community into which your product service system is going to be offered. Enable responsible and sustainable consumption. This is to design stakeholder interaction fostering for economic and competitive reasons, and responsible and sustainable end user or client or, let's say, customer sustainable behavior. And this could be with different level of involvement, and you will see different examples. You can say that simply you design something and you offer something by which the customer or the end user is informed about the sustainability of your offer, so that he can or she can select this, or the final user could be some more involved into the offer. You will see some example into which the end user is even the designer, or is co-designing, or even co-producing the product that then he is using. Okay, so you will see that this could be on different level of involvement. Favor, integrate weak and marginalized, so designed for stakeholder interaction, fostering for economic and competitive reason, the improvement of the life quality of either weak and marginalized. Okay, weak basically are kids, elderly, people and differently able people. Marginalized are those people that are, for example, unemployed, illiterate, or have some problem of drug addiction or something like this, okay? And you will see example how, and even in this case, it could be integrated in different ways. Design to improve social cohesion. So again, stakeholder configuration. And when we speak about social cohesion, it could be on different levels. Here I'm a bit schematic, but forgive me for that. The integration could be, let's say, on a neighborhood level. So those people living closer to me. Maybe you are living in a house, you need to know who's living in the same, in the door nearby yours. But the integration could be even between generation. If we are speaking about intergenerational dialogue between the youngest and the oldest, but even other ages, between genders, male and female, and between different cultures. And this is a beautiful place, different culture, even different gender. I don't think you are living all close together, so not really in the same neighborhood. And basically you have the same age, but and then I don't know whether this is the last one. Empower and enhance local resources, so design system stakeholder interaction, fostering for economic and competitive reason the regeneration and empowerment of local resources. Local resources could be either natural resources or human resources. And okay, I don't go into the detail of this. You will see examples, but we understood how this is important. Again, as for the environmental criteria, we have guidelines for all of these 6 socio-ethical criteria that we have been developing. So we developed it from the guidelines. And again, the guidelines are on a level of stakeholder interaction, not how to design a product, but more and before in terms of stakeholder interaction. Here again, there is the example of the sustainability design orienting toolkit, and here you will be using the idea generation table with the 6 criteria and with the guidelines inside and with a link to the example and so on. Okay, I'm going to complete this part just with one last, but not that, but quite important notation. In fact, it will be even part of your design process. We saw this criteria. It's important to give priority to those criteria. Because for a given context, we will be designing an eating system. It could be that if we look at the environmental criteria, system life optimization is the most important thing, or toxicity reduction is, or vice versa. Basically, since we are speaking about food, toxicity linked to intensive agriculture and other things is quite important. The resource consumption is quite important as well, and other things maybe. So the understanding of the relevance of the different criteria, and maybe waste minimization is, well, we have to do something, but it's not that important. It's key important. You remember the example we made on product, the bad example, in which they designed for easy the chair, so that it is made of renewable and recycled material, so, but then it doesn't last anything. So it was considering one design criteria, which is good, designed for using recycled material, but then it resulted in one of the worst examples. So you have to understand for a given product, which is the most important criteria to follow. The same is on a system level. You have to understand this, because then this will enable you to address your design efforts. You know that, for example, system life optimization is the key criteria. So I will give a lot of efforts and I will concentrate on these criteria first. And if this is in conflict with another, because this may happen, you may design for recycling, but designing for recycling could compromise the durability of the product, which is another criteria. Sometimes this happens. And if you know the priority, you know, well, I selected one that is more important for my system. Okay? So it's good to identify which of the criteria, both among the 6 environmental and the 6 socio-ethical, has the highest priority, we say, because then this will help us and address our design effort. And even for that, we will be using the SDO toolkit. In this case, there is not a quantitative analysis as for the life cycle assessment. You remember, to assess the product, there is this tool that assesses all the input and all the output coming up, you know, with the greenhouse, global warming potential, and blah, 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 blah. In this case, we are using, because the system is quite complex, checklist, so qualitative system. You can use even life cycle assessment sometimes, but you have to be really very tough. The system could be complex. Once we did it, and we get crazy about it. And you will find as well in the same tools checklist for assessing of an existing system the environmental problem related to each of the criteria. So you will understand not through a quantitative analysis, but through some qualitative question. When you answer to the question, you get to know whether there is a problem under or not. So you will understand whether which are the problem at first and which is the criteria with the highest priority.